we need to measure the position of a straight slot at a specific basic angle. So in Calypso, I'm going to create a symmetry plane. I'll select Define Points, create that plane using a variety of points on both sides. Make sure you take these points at different levels, because if you do them in a straight line, Calypso won't be able to construct a plane. So these opposing points together create what's called a symmetry plane. This is a feature of size, and it allows you to report the distance across or the width of that plane as well. So we're going to report that, and we'll just call this slot width and click OK. So now, how do I get the position of the slot since it's not lined up with my alignment? Well, there's two approaches. We can create a position on that symmetry plane relative to our base alignment or whatever datum reference frame that you have set up. And then you go to Special, and then we click Rotate by Angle, and we're going rotating around the Z-axis. This will be 30 degrees, and this shows the temporary rotation. Actually, that's going to be 36. So let's go back here and fix that. So this is our temporary rotation for this position only. So it's not really a new alignment that's usable anywhere else. And because of that, I often like to use a secondary alignment, which you can get from Resources, Utilities, and Alignment. And right in here, we can do a similar thing. We can go to Special, Rotate by Angle, put in your angle. And now if we need to use this alignment for other features, we can do that as well. So now in our position, instead of base alignment, I'm going to pick alignment 1. And we have to take away this extra rotation because it's doing it twice. And now it's lined up. So notice our position is only in the Y direction relative to this angled alignment, and the coordinate should be 0. So this will give us the offset in this direction, either plus or minus, and it also will tell us the worst case twisting of that slot. So even if the center point is perfectly on 0 in the Y, but it's twisted, this calculated result will give us the worst case times 2 as you compare it to 0. Now, since this symmetry plane is a feature of size, we can use the MMC modifier here. So we will have bonus tolerance, and we'll look at our drawing. It's 0.787 plus or minus 4 for the size, and 0.006 at MMC for the position. Now I'm currently working in metric, so switch over quickly to inches. And we've got our slot width, which is plus or minus 4 thousandths. And our position of 6 thousandths at MMC, which means if the slot width is bigger than the smallest allowable size, we can have more position tolerance. So our smallest allowable size is 0.783. If the slot is 0.785, that would be 2 thousandths away from MMC, and we would add that on to the 6, so we could have 8 thousandths. So if the slot is the largest it possibly could be, 0.791, that's 8 thousandths away from MMC, so we could have up to 14 thousandths or 0.014 position tolerance. So effectively that would give you 7 thousandths positive or negative from the center. And this is all relative to our angled alignment. Now to do all of these slot positions, you would create separate angled alignments for each one. Unfortunately, you can't pattern the alignment that is angled, but what you can do is you can create extra alignments that leapfrog from the first one. So we're going to reference alignment 1 for the second one, and it applies the offset from there. So you'll notice now it's angled at this second slot. So then we can copy this one and reference alignment 2, and so on. So there you have it, slot width, position with different angled alignments. And let me know, guys, if that makes sense. If you have any questions, leave a comment, and have a great day.